when you are drawing these diagrams, we want to go over here to shapes, and then we want to use the insert line tool to draw the diagrams, okay? And I'm just gonna make my arrows purple. You can make them any color you want. I'm also using a thickness of 2. You can also use a thickness of 1. Okay, I think a thickness of 1 actually works a little better, so I'm gonna switch to that. But here's what you wanna make sure that you're doing. You want to make sure that arrows always have the arrow head. I literally don't, I think that's what that's called. Like this little section of the arrow where it's showing directionality. You need to make sure that you have that, okay? That was something that last semester I found a lot of students were just not including the little kind of those 2 arrows those 2 little lines at the end, okay? So please make sure you're including those, okay? So as we're drawing these, again, I'm going to go to shape, and I'm going to start at the box, and I'm going to draw a gravity force downward. And I'm trying to make sure all 3 of those little lines intersect, but like y'all, as long as it's like close, we're good, okay? I'm not looking for perfection. I'm looking at like, I can tell that you're trying your best type of deal, okay? So gravity, all objects on Earth experiences gravity force that is directed towards the center of the Earth. So for us, we are going to show that by always having gravity force pointing directly toward the bottom of the page. And then we label it FG. And I type an uppercase F and a lowercase g, okay? Ideally, we would have the G as like a subscript, but this works, okay? Again, this is all kind of learning how to do this within Kami. Okay, so again, this object is on an incline, but it is on planet Earth. So we have our arrow pointing towards the bottom of the page, and I label it with FG, okay? So that's gravity force. All right, so next we have normal force. And again, I'm just taking this text from page 2. Normal force is, so the question we want to ask ourselves with normal force, like, does an object have normal force? Is the object being supported by another object? If yes, then it has support force. Or I'm sorry, then it has normal force, right? So right now, my body, I kind of am like shifting my weight between my feet, which are resting on the floor, and my chair, right? So my body weight is being supported by both the floor and the chair. So the floor and the chair are giving me normal force. They're pushing up and they're supporting my body. They're making sure I'm not just falling through space. If I'm standing, 100% of my body is being supported by the floor in this classroom, okay? That's what's making sure that I'm not falling through to the floor below, okay? So this is a support force exerted upon an object that is in contact with another stable object. And this is tricky because this is one of those invisible forces. So when you're thinking about this, I want you to think, have you ever seen someone sit on a chair and they break the chair? Like, do we have that kind of mental image of someone like sitting down and the chair cannot support their weight? That's because the chair is trying to give normal force but can't give enough normal force, so the person falls. The gravity force wins out, okay? So an example of this would be the book sorry, street cleaners going by. An example of this would be a book resting on a table. So this would be, so the book would get normal force from table. This is always drawn perpendicular with surface. Okay, so let's just kind of see how that looks over here on these objects. So both of these objects are on planet Earth, so I'm going to have little forces going down. And again, these are always going down to the bottom of the page for gravity force. I'm just going to label these FG. And then for my normal force, I have them perpendicular to the surface. So for this first box, that's just going to mean straight up and down. Okay. And you can kind of notice I'm trying to like make these balanced. I'm trying to make these arrows the same length. Again, this is something I'm not going to, with a ruler, measure your arrows, but you should be able to look at the arrows and see, okay, those are about the same length. Okay. We label normal force with Fn. For this one, again, perpendicular to the surface, which here means it's going to be at an angle. And I'm trying to make those arrows, again, about the same lengths, and that would be Fn. Okay. All right, so the final force that you all learned about is Fp, which is a push or a pull force. So for this one, again, just taking this text from page 2, this is an applied force through contact. Okay, so contact is required here to, through contact with, sorry, my wording is goofy here, to contact to an object by another person or object. So an example here would be you actively pushing something. Okay, so let's say that you are trying to push something across the table. That's you having a push force. Another example, and this is where we see this more frequently, is one object pushing down on another object. Okay, so remember I was talking about my chair is supporting my weight right now. I'm sitting in a chair, so I have Fn pushing up, supporting my weight. But at the same time, I am pushing down on the chair. Okay, so for example, if we look over here at these boxes, box A is pushing down on box B. Okay. So let's go ahead and draw these out to see what these would look like. Okay. So if I am just going to draw what the free body diagram for box B would look like, I'm going to kind of draw this just like this, just to make this off, like segment it off a little bit. What we're going to end up having, so box B is on planet Earth, right? So box B definitely has gravity force. Oops. Actually, here, let's do this. Oops. Okay, so let's say that this is box B on its own, and then this is box A and B together, okay? So if box B is on its own, it's going to have gravity force pointing down, and it's going to have normal force pointing up. And ideally, those should be kind of in the center, but it's okay. So, Fn. Okay, so this is box B just kind of on its own. Box B, when it has box A on top of it, so we're still going to have Fg. Oops. I'm just going to delete that line. So we're still going to have Fg. But now we're also having Fp. And Fp is from box A pushing down on box B. Okay. So then when we think about Fn, so the surface beneath box B, let me just draw this in really quickly. This is on a surface, this is on a surface. The surface beneath box B, do we see that it's supporting both of the boxes? So we have to accommodate for that in our Fn. So our Fn here is much larger. And we're going to see this in a couple of different examples. But what ends up happening is Fp plus Fg are going to be equal to Fn. Okay? The last thing that I wanted to talk about before we move on, so we should have read through this all thing. Towards the bottom of page 2, we just need to know that a low magnitude is going to be a small arrow. A higher magnitude is going to be a large arrow. Okay, so the higher the magnitude of the force, the longer the arrow. Something else that we want to think about is any downward and to the left forces are negative. Upward and to the right forces are positive. And you'll see some examples of this when we actually start going through these examples, but I just wanted to make sure that we make a note of this within this space. The second thing that I wanted to note was it's saying that if an object is at rest, we say that the forces on the object are balanced. So if the forces are balanced, that's going to equal arrows that balance out in length. And again, we'll see some examples of that.